Hi, this is Mrs. Meyers, and this is a review video for Chapter 1. I'm just going to highlight a few things that you need to make sure that you know. First of all vocabulary. I am not listing all the vocabulary here, but you need to look into your notes and find all the vocabulary words that we learned. They're also in the book. They're also in the back of the Chapter 1 in the review section. They have them all listed there. So make sure you know all the vocabulary words. You don't need to define them on the test, but you do need to be able to recognize what they mean. Make sure you know the notation for all of the words, lines, segments, and planes, etc. Make sure you know how to mark up a diagram with congruence marks and everything. I'll just write that here. Label diagrams. I'm putting this kind of with vocabulary because you have to know what bisect means to be able to know that if this is an angle bisector, you are going to mark your diagram with congruence marks, if that's a bisector, etc. And midpoint, you would need to know how to mark your diagram. Okay. Basically, the notation, you've got segment, you've got ray, you've got line. Be clear on all of that notation. The other thing you need to make sure you understand about the notation is that when you have AB, it means the segment itself. When you have AB with no symbol, it means the length of AB. And similarly with angles, if you have angle ABC, it means the angle itself. And if you have the measure of angle ABC, it's the degree measure. So pay close attention to this notation. Remember that here you could use a congruence mark for both of these, and here you would have to use an equal sign for both of those. Okay, just a reminder about intersections. We talked about yellow and blue makes green, right? Intersection is the overlap. So think yellow and blue makes green. And the green part is the intersection. So if we have some rays like this is point A, this is point B. If I want the intersection of ray AB and ray BA, I'm going to make ray BA first, start at B, go through A, yellow, and then start at A, go through B, blue, and the green part, the intersection, is segment AB, right there. Okay, if you look at this diagram I have here, this is just a little example similar to the ones that we have done in class. If you have this diagram, notice they've marked this and this angle congruent. They've labeled this 3x, so that means I can label this 3x. You need to know this symbol means 90 degrees. So if I were going to write an equation for this, you have to remember that writing your equations means label the diagram first, then write the equation, and the equation has to has to match your diagram. So in this diagram, I know this whole angle is 180 degrees. So I'm going to start here, and I'm going to say 3x plus this middle angle, 90, plus this other angle here is also 3x, equals the whole thing, which is 180 degrees. And then I would solve that equation. Make sure that your equations are matching exactly what's going on in your diagram. Okay, so then there's some postulates that we learned. So we've got angle addition postulate, and we've got segment addition postulate, and we've got the linear pair postulate, which just said that if it's a linear pair, it adds up to 180 degrees. It's supplementary. Okay, don't forget about all the angle pairs. We had a lot of them. Learn all of that vocabulary as well. So we're talking about complementary angles, supplementary angles, vertical angles, adjacent angles, linear pairs, etc. Okay, if we look back at this diagram again, a linear pair in this diagram would be, say, this green angle and that purple angle. Together they would make a linear pair. They're also adjacent angles because they share a side. If I were going to name this, I would say angle ABC and angle CBD form a linear pair. Oopsie. Okay, now I want to just go through this review with you, and we will do it together. Use the diagram to give an example of each of the following using proper notation. So I'm going to look at this diagram and I'm naming a line. There are two lines in this diagram. There's one here and there's one here. So I can name either one of them, and remember, naming a line, pick any two letters in any order. This says name the same line two different ways. So I don't want to name the two different lines. I want to pick, maybe I'll name this line, and I'm going to call it AB. I could call it BA. I could call it CB. I could call it BC. I could call it AC. All of those, but remember your notation with the two arrows on top. Okay, the next one, a ray, the same ray again, two different ways. So I am going to choose that same area here, and I'm going to say this ray. I'm going to name this ray that I'm highlighting. It starts at C. It goes through B and continues forever. But it also starts at C and goes through A and continues forever. So that is the same ray. Both have the same endpoint. A segment, two different ways. Let's skip to this one now. I'm going to name this segment QR. And if I want to name it a different way, I could call it RQ. Okay, the intersection of the two planes shown, they come together right at this line, and since planes go on forever, you have to name that as a line this time. Arrows on both sides because these planes go on forever, and so does the line. The intersection. The intersection of plane QRA and line BC. Again, think about yellow and blue makes green. If I'm talking about plane QRA, I'm going to highlight plane that contains QR and A. And then I'm talking about line BC. I'm going to highlight in blue line BC. What turns green? All of line BC turns green. So the intersection is the whole line. Three collinear points. Remember, collinear, another vocabulary word, means that the points can be contained by the same line. So collinear points, if I need three of them, my only choice is to use this line here with the 3 points on it. So three collinear points would be A, B, and C. Three non-collinear points, well, now I have to involve another point from this line over here. So I could take 2 from this line AB, and I could choose 1 over here, or I could use Q and R and 1 from the other. 3 non-collinear points, let's say A, B, and R. Okay, a pair of opposite rays. Remember, opposite rays have the same endpoint, but they go in different directions, opposite directions, so that they form a line. So I'm going to choose this ray, which is ray BA, and this ray, which is ray BC. Both have the endpoint of B, so I need to name it with B as my first letter. Remember, the arrow is one arrow always pointing to the right with the notation for array. Okay, so draw a sketch and label as needed. Do the best that you can with the drawing. So 3 collinear points A, B, and C. Collinear. I'm just going to line them up. You don't need to connect them, but you can to show that they have a line going through them. Number 10, MN intersecting AB at point R. Oh, this is hard to read, but I think it says line MN. And I'm sorry, does it say line or segment? I can't tell. Maybe yours is clearer than mine is, but I'm going to call this line MN intersecting line AB at point R. So I'm going to say MN with 2 arrows, if that's what that notation is. It's hard for me to read. And AB, A is here, B is here, and it's intersecting at point R. Okay, coplanar points, W, X, Y, and Z, all on the same plane, so I'm going to just kind of draw a plane like that. Collinear rays, collinear, so they're on the same line, so I'm going to call this JK, and this one JC, but they're on the same line. Okay, here's our review, and we're going to go to this page. The given information here is that AB is 14. We're going to label. AC is 42. BC we're going to call X. So we're going to say our equation is 14 plus X equals 42. Segment addition postulate says one part of the segment plus another part of the segment equals the whole thing. Next one, TAC is congruent to angle CAG. So TAC is this angle, CAG is this angle. They are congruent to each other. So TAC is x plus 20, and TAG, label carefully, is 3x minus 10. That's this whole thing. Now I have to write an equation that makes sense from this diagram. Well, if TAC is congruent to CAG, then I could make this x plus 20 also. Now, angle addition postulate says this angle plus this angle equals the entire thing. So that's the way we want to write our equation. X plus 20 plus another x plus 20 equals 3x minus 10. I'm not going to work all these out for you, but know that here the answer was 5. This was 120. Oops, sorry, 50. And this was 140. Here x was 28. C was 28. Okay, let's look at the next one. Angle ABC equals 20x plus 24. Angle ABC is 20x plus 24. And CBD is 10x plus 6. We need to recognize that these two angles form a linear pair. They are sitting on this line, ABD. So they're sitting there adding up to 180. So 20x plus 24 equals, plus 10x plus 6 equals 180. Very hard to write in a small box here. That one turned out to be 5. Okay, the next one, number 19, angle NMO is a right angle. That makes it 90 degrees. LMN, label carefully, this is 6x minus 15. And LMO is the big angle. LMO is this whole thing is 13x plus 5. So again, angle addition postulate. This angle plus this angle equals the whole thing. So 6x minus 15 plus 90 equals 13x plus 5. That was 10, 45, and 45. Okay. Last one like this here says LE, ray LE, bisects RN. Bisects means cuts RN into two congruent pieces. So RU is congruent to UN. So point U is called the midpoint of RN. If RU is 7x plus 12, here, and NR, that's the whole thing, is 16x minus 20. Then when we write our equation, remember we can make this 7x plus 12 also, and our equation would be 7x plus 12 plus 7x plus 12 equals 16x minus 20. Another way to write that is 2 times 7x plus 12 equals 16x minus 20. Either way, your answer there comes out to 22, and RU is 166, and NR is 332. Okay, decide whether the statement is true or false, and briefly explain your answer. Lines have endpoints. Nope, that's going to be false. Okay. False because lines go on forever. I'm going to abbreviate here. Planes have edges. False again. Planes also go on forever in all directions. 3 lines that intersect at the same point must all be in the same plane. That's actually false also, because you could have a plane like this containing 2 of the lines intersecting at this point here. And then imagine this line coming through that same point, not in the plane. So it's come piercing through that plane like that. Okay? And 2 planes may intersect a third plane without intersecting each other. That is false also. Oops, sorry. 2 planes may intersect a third plane without intersecting each other. Actually, that's true. Because you could have a plane like this and a plane parallel. Picture a parallel plane. And then a third plane can kind of go through both of these. Oops. Like this. So it's going through both of the planes, but these 2 planes are actually not intersecting each other. Okay, complete the following using the diagram at the right. Angle addition postulate. LMN plus blank equals LMO. So here's LMO. I need to fill in that blank with this angle here, and I'm going to call that NMO. Make sure you have the angle symbol there. Segment addition postulate. One part of the segment plus the other part of the segment equals the whole segment. So PM they have for us, plus, let's add MO, equals, and that's going to be the whole thing, PO. Circle the 4 expressions that make sense, one from each column. So If we have the choice between these two expressions, this is going to be the correct one because we have a congruence symbol, and you must have the marks over it, over the segments. XY equals 12. Since it's an equal sign, there should be no symbol over the XY. Here we have a degree measure, so it's the measure of the angle, so we need the little m for measure. And here we have a congruent sign with little m's, and that's not okay. If there was a congruent sign, we would take away those m's, and then it would be okay. So since we have the little m's, we need the equal sign. Okay, complete the following sentences. Two distinct planes intersect at one line. Always, that was the postulate we learned. Through any 2 points, there is exactly one line, another postulate. Okay, use the figure. Are points O, B, R, and C coplanar? Let's find out. O, B, R, and C. Ooh, you might think no at first, but I actually can put a plane diagonally through this shape like this. Goes through diagonally. I don't know if you can see what I mean there, but it could go through diagonally. So actually, yes, these are coplanar. Name 3 lines that intersect at P. Here's P. So 3 lines would be OP, BP, and QP. What is the intersection of plane AOB and plane POR? AOB and POR. AOB is this plane. POR is this plane. So they intersect at OP. And 2 planes intersect at a line, so you need both arrows there. Draw a sketch of the following. Make up values for any angles or segments that you draw. Okay, so an acute angle, and you would make up any number here, you know, less than 90 degrees, so say 32 degrees. Obtuse angle, make up any angle here that's greater than 90 degrees, so maybe 150 degrees. And YG, segment, YG, so 2 endpoints, because it's a segment, not a line, with midpoint at A, so you're going to put the A right in the middle. Make sure you're marking those congruent, because that's the only way to know that's the midpoint. If you were going to make up numbers, maybe 10 and 10. Straight angle, X, Y, Z. Remember, Y is the vertex, so that has to be in the middle. Straight angle is 180 degrees, so maybe we'll label that. All right, the last part here, using proper notation, lists all the information given by the marks. Here there's really only one thing you can say, and that is UT is congruent to SR. Over here we have 2 things, actually 3 things. GH has 3 tick marks, and so does DC. So GH is congruent to DC. Then we have 2 tick marks and 2 tick marks, so EG is congruent to ED. And the last thing I see here is this right angle. So you could say GD is perpendicular to DC, or you could say that angle GDC, measure of angle GDC equals 90 degrees. Or you could say angle GDC is a, oops, that says DDC. We want it to say GDC. GDC is a right angle. Okay, remember, this is not the only studying for you to do. You need to make sure you go through your notes and be ready for the test. Good luck.